And 3.3 notes, this is solving linear inequalities. So we kind of did this last chapter in chapter 2 right at the end, where we had to graph these things and see if they're dotted, if they're solid, line, where to shade, all that stuff. So you got dotted versus solid going on. You got shading, all of the above. But now we got 2 of them. So my first one, I got this equation, so I start at 1, 2, 3, 4, 5. My slope is negative 2 over 1. 2 over 1, up 2 over 1, up 2 over 1. Kind of helps if you put all those dots in there because you want to see what's going on. And then I'm going to use my fancy ruler so that now when I connect the dots, they make a nice line. And I almost messed up, but look, it is a solid line, so that one works. This one is going to be a dashed line, and I need to solve for y, so I got y less than x plus 3, so I start at 1, 2, 3. And I go up 1 over 1, down 1 over 1, down 1 over 1, etc. And this one is the dotted line, so I'm going to dot this thing beautifully like that. And now I need to figure out where to shade. So for my solid line, it was greater than, so I'm shading above that line. For my dotted line, I'm shading below. So your answer for this is like where they both are. So I'm going to double shade this, make it nice and extra dark for you. You can see this area, that shape, would be my answer. Let's do another one. I'm going to solve for y here, so I got 2y greater than or equal to negative 4x plus 8, y greater than or equal to negative 2x plus 4. So I start at 1, 2, 3, 4, and I go down 2 over 1, down 2 over 1. Solid line here. Nice. And then my other one, I start at negative 3. And I go down 2 over 1. So you know right away these are parallel. This one's a dotted line. You can tell right away that they're parallel. So they're never going to intersect. But then shading-wise, this one says it's greater than, so I'm going above it. This one says it's less than, so I'm going to go below it. X less than 2, so it's going to be a dotted line at 2, going straight up and down. And the other one, I'm going to solve for y, so I got 6x. So that when I solve this thing, I got y less than or equal to, because I divided by a negative. This is 1/3 x minus 1. So I start at negative 1, I go up 1 over 3, up 1 over 3, put a couple dots in there. I got a solid line happening, a nice solid line. And then I got the shading to do. So this one is less than 2, so we're talking everything back here. And then this one is less than, so I'm talking below. So where's my double shaded? Make it a little extra dark. And there you go. One more. Y less than or equal to 3. So I go 1, 2, 3, and I go solid line straight across. Ooh, and this one has got the absolute value, so it's going to be a V. So my vertex is negative 4, negative 5. So I go 1, 2, 3, 4, 1, 2, 3, 4, 5. And my slope is 2, so I'm going to go up 2 over 1, up 2 over 1. And it looks like it's a dotted line for this one, so I'm going to make it sure I make it dotted. Go on both sides. Now, for less than 3, I'm talking anything below 3. So that one's anything below. And for my greater than, for this, I'm going to plug in 0, 0. So I got 0 greater than 2, 0 plus 4, minus 5. So when I solve that, I got 4. 2 times 4 minus 5. 0 greater than 3. 8 minus 5 gives me 3. 0 greater than 3? No. So right here is 0, 0, so that means I'm shading on the inside. So my double shaded is like this little triangle in here. Okay, one more word problem. It says you are going to a summer camp for 1 week. You have $90 to spend on extra activities, and you figure out you will have 12 hours or less of free time for extra activities. You want to spend your time rollerblading and paddleboarding. The rental fee for rollerblades is $6 an hour, and the rental fee for paddleboarding is $10 an hour. So the first thing it wants you to do is write a system of equation representing the constraints of your time and your money. So let's say X is time. We'll say Y is your money. So first, let's talk about what do we got? First one is my time, my $6 per hour and $10 per hour. Oh, X and Y are then, okay. X and Y are supposed to be rollerblading and paddleboarding. Whoops. So for rollerblading, it's $6 per hour, and paddleboarding is $10 per hour. So 6x plus 10y, and I have $90 total to spend. So I can't go over 90, so it's got to be less than or equal to 90. My second equation is probably talking about time here. So I got 12 hours or less of free time. So together, between rollerblading and paddleboarding, I have less than or equal to 12 hours. So that when I graph this thing, I'm going to go by 2's here. So we'll start 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, that's good. And the same thing up here, we got 2, 4, 6, 8, 10, 12, 14, 16. That'll be good for now. So when I'm graphing these things, my first equation, I got 10y less than or equal to negative 6x plus 90. So that when I divide by 10, I got y less than or equal to negative 6 over 10x plus 9. So I start at $9 basically, or 9. I start at 9 here, and it's, what's that, 8, so 9. And then I go down 6, 1, 2, 3, 4, 5, 6, and over 10. And over 10. And I got a solid line because it's or equal to, and it just includes right in there. And then my other one, I got y less than or equal to negative x plus 12. So when I graph this, I start at 12, and then I'm going like down 1 over 1, down 1 over 1, or down 2 over 2. It's the same thing happening here. So when I graph that one, I got another solid line. They're both less than, so my double shaded area is this, that part. So if you need to interpret the graph, the shaded area is where rollerblading and paddleboarding work with your time and your money constraints.